Evening, ladies and gentlemen. I'm sorry to disturb this raucous conversation. Can I welcome you along here this evening? It is very good to see so many people. My name's Giles de Lebanier. I'm one of the Lignacite team, and I'd very much like to welcome you here this evening. A particular warm welcome to a number of our previous speakers who are here. And I can see one or two old favourites who have been a number of times. We have now given, I think, 11 lectures in London, and if you laid all of the people who have fallen asleep while I've been talking end to end, they would stretch out and be a lot more comfortable, I can tell you. If you enjoy this evening, please let me know. If you don't enjoy it, please see Beth or Shirley, who are on the front desk and have much broader shoulders than me. If you do, by the way, fall asleep, and you're next to someone or next to somebody who falls asleep, please don't wake them up while I'm talking. When Michael Paulin comes on to speak, please give them a nudge, because I have heard him speak before, and I know that what he's going to say is going to be absolutely fascinating. And we're extremely grateful to Michael for agreeing to come along and talk to us tonight. I am the sort of warm-up act, I'm afraid, and he will then be talking about the serious business. What we want to talk about this evening is our world and how nature has adapted to survive in that world. We want to look at how we can learn from that and then to apply that knowledge in the built environment. And as I say, I'm going to speak first, and then Michael is going to give us, I think, a real glimpse of the future. We're going to talk for about an hour, and we will take questions at the end, if we may. Following that, we're going to be back upstairs in the library, where there will be some more food and more drink. So don't ask too many questions, is my suggestion. I'd like to start at the beginning. And I've got two children here this evening. They're both at Durham. One is reading theology, and the other is reading zoology. And most of the pictures are of animals, and my daughter, who is reading theology, complained about this. So we're going to start with a little theology and go to Genesis. And I'm not here tonight to convince you necessarily of creation, but what amuses me and interests me is the order in Genesis, which I'm told by scientists is absolutely spot on. How they would know that the heaven and the earth and light and darkness came before woman, for example, is a difficult one for a start. But anyway, that is the order. So that is the order in Genesis. And of course, on the last day, God rested, and thus the heavens and the earth were completed in their vast array, and God saw that all he had made, and it was very good. And we do live in a beautiful world. This is a southern stingray, and he's clearly on his holidays in Barbados. He's just off to his yacht, as you can see. This is a giant clam who lives on Kingman Atoll in the Central Pacific Ocean. Now, this clam has died out in most of the world, but he survives in this untouched shallow water coral reef merely because it is in the middle of an ocean, and no one's really come across it. Our world is very fragile, and this is a crinoid, this chap, and he's called Feather Star, and he's living on a red fan coral, which is a thing of great beauty, in Indonesia. We live in a world of plenty, but one that survives in balance. There are many species, obviously, which have evolved in different ways over millions of years and have thus survived, and a lot of them have done that in resource-poor conditions, and therefore they're incredibly efficient at what they do. This is a chambered nautilus in the Coral Sea in Australia. Many plants and animals have specialized so that they can live in really hostile environments. I'm a very keen fisherman. Where's James Blake? James Blake very kindly invited me to fish on the Test a few weeks ago, which was quite fantastic. And one of the flies that we used was made of deer hair. And deer have got hollow hair, which means if you tie it into a fly, it will then float on the surface. Polar bears, the same. And you imagine if a koala bear was put into this sort of environment, clearly he would not be very happy at all. Plants also have adapted in incredible ways. This is a mangrove swamp, and these roots have got breathing holes at the top so that they can live underwater. So whether you're at the depths of the ocean or the highest point on a mountain in the world, some creature or plant has adapted in some very special way to survive and exist. And actually the most adaptable creature on the earth is man. We exist everywhere, in almost any situation. However, are we being responsible with our world? This poor female mako shark has been killed for her fins, and the rest of her will just be discarded and thrown away. Now, that is obviously tragic and a terrible waste, but nature will recycle her body very quickly. In fact, nature recycles really almost everything. There is precious little waste in the natural world. Whether it's vultures or dung beetles, protein or poo, nature cleans up after itself and nothing goes to waste. Spiders, when they are mending their webs, they eat the silk around firstly and then regurgitate it and build their web again. Crabs, when they are building a new shell, will absorb most of that shell before they discard the old one. So nature is highly efficient and not wasteful at all. The same, very sadly, cannot be said of us. We have made a right mess of this planet. And if you see scenes like this and you think of events such as the Deepwater Horizon oil disaster in the Gulf of Mexico a couple of years ago, it just shows that we are not being very intelligent, very clever, very responsible with our world. I very much like this quote of Tim Schmidt's from the Eden Project. Michael, as you probably know, worked for 10 years on this project while he was at Grimshaw's, and I'm not sure, but maybe he's going to touch on that later. So, what are we doing? The construction industry has a turnover of 2.9 trillion a year. That's worldwide, not in the UK. George Osborne wouldn't be having quite the problems that he has at the moment if it was in the United Kingdom. But that is worldwide. We are, the construction industry also worldwide creates 45% of the CO2 that is released. It uses 60% of the materials by weight. And 12% of the CO2 emissions are associated with just moving materials around for building. This bottom figure is really scary. 20% of all construction materials go straight to landfill. So, if you think about it on a housing estate, and grateful to Michael again who pointed this out, if you go to a housing estate, every fifth house that you look at goes straight to landfill, in effect. In the United Kingdom, we produce, or we release 50 million tons of embodied CO2 every year. Now, just I mentioned embodied. If we look at the whole lifetime of a building, there's the good old 80-20 rule kicks in. 20% is released while you're quarrying, transporting, manufacturing, and building that building. And then the rest of the lifetime, the operational heating, hot water, lighting, and power accounts for about another 80%. just have a little think about population and where that is going. There are currently roughly 7 billion people in the world, and half of us live in cities. It's been estimated that by 2050, the population will be 10 billion. And because of increased urbanization, those living in cities will have risen to 7 billion. So, the urban population will double in the next 40 years. What does that mean? Well, it means actually that we need to start building now. And we need to start sourcing the raw materials as quickly as we possibly can, and really, really thinking about how we are going to provide for those cities and people to live in them. What can we do about it? Well, it's all very well looking at massive pictures about the world and what they're doing. We can really only control and influence what we are doing. And just to sort of cover at Lignacite what we are doing, we make blocks. We've got a couple of factories, one in Suffolk, one in Essex. In Suffolk, we have recently invested far too much money, my chairman keeps telling me, in a brand new state-of-the-art factory that is insulated to the gunnels. It's highly efficient from both an acoustic and a thermal point of view, to the degree that when we've made our blocks, we put them into kilns and we don't need to add any heat at all. They cure themselves. Now, unfortunately, our factory in Essex is much older and more knackered and not as efficient, and when it gets cold, they don't cure. Now, what we've done, or what was initially done, our operations director, who's here somewhere, Alan Eastwood, went off to the dump and collected 8 old fridges that had been thrown away. He cut the backs off, made holes in the kilns, stuck the fridges into the kilns, turned them on, and the fridges are just heat pumps, really, so they produced a little bit of heat, just sufficient to raise the temperature by a couple of degrees, and that was sufficient to start the exothermic process of cement cooking off. Cement just needs a little bit of heat and a little bit of moisture. The crystal starts to grow. Once it's grown, it goes hard, and that's what holds everything together. That's the technical how cement works thing. Now, clearly, OPC, ordinary Portland cement, is a baddie in terms of carbon dioxide. To make it, you release enormous quantities of CO2. So we need to do something about that. And we're looking at a number of things. We're using something called GGBS, granulated blast furnace slag, which is a replacement for cement. We use about 10% in our products. We are looking at alkaline binders, but again, at the moment, those are very expensive, and commercially it's very difficult to make that stack up. We're looking at other interlocking drywall systems that use less mortar or are just intrinsically stronger and so don't need so much cement. The other thing that we're trying to do is we try and use materials that other people are throwing away. So whether it be shells, glass, ash, wood, whatever it is that people are discarding, we take it and we try and use it. So shells, for example, from King's Lynn, which is near us in Norfolk, the shellfish industry brings ashore tons and tons of shells and shellfish. They take the shellfish out, they throw the shells away. Sometimes they're used on golf courses on the paths, but basically they go to landfill. So we've started taking them and using them and putting them in our blocks. And what we found is that they're very strong, they're very light, they're very beautiful. They make absolutely wonderful blocks, and we've moved from using shells onto using mother of pearl. And you'll see upstairs when we go up and have a drink some examples of just some of the natural products that we're putting into our blocks, which have which really create very, very stunning effects. I want to just leave glass and ash and move on to wood for a little bit, because Lignacite was founded on wood. My grandfather started the business in 1947, and he was living in Suffolk, and he was just after the war, he was approached by an inventor who said, "I've come up with a magic ingredient that you can add to wood and sand and cement and make a fantastic block. Do you want to give it a go? So he said, okay. He recruited his sergeant major from the engineers, and they started to make blocks. This magic ingredient was an additive. It was very expensive, and one day we ran out of it, and my grandfather just said, carry on, sergeant major, without the additive, which he did, and of course the blocks made even better. The inventor, or the chap who approached him, was later chased to Europe, and it turned out he was a complete fraud. But the point of the story, in a way, is that really the magic ingredient in those blocks was the wood. Wood is absolutely brilliant stuff. We haven't changed the mix design. We're now on our 4th generation. Here she is. She's not in the audience, but her elder sister is. But the point of this is that for 65 years, we haven't changed it. Wood in blocks makes them light, smooth, warm, soundproof, very good in a fire. But perhaps most importantly, and certainly for this evening, it locks up CO2. This is me, rather sadly, standing in front of a whole pile of graded wood particles, GWP. Plants obviously capture CO2 through, as they grow, through the process of photosynthesis. Easy for you to say. Wood locks up 800 kilograms of CO2 for every cubic meter. Hemp and straw lock up 211 kilograms for every cubic meter. So wood is 4 times more effective than hemp or straw. This sawdust used to be produced by a company local to us, and we bought it from them. We liked them so much that we bought the company, and we then converted a couple of old post office vans which go around the country to builders' merchants and wood yards. They collect offcuts from doors and windows. We then put it through a miracle mill, grind it up, wash it, and put it into our lignacite block. You'll remember from school your Latin. Lignum is the Latin for wood, hence lignacite, and the name of our company and the name of this product. Every metre of 100 mil lignacite blocks lock up 12.3 kilograms of CO2. So, where is this being used? Well, here hopefully is a building that you've seen recently. Lignacite has been used on 7 of the Olympic projects, Olympic buildings, the stadium, the velodrome, the Westfield shopping centre. And in fact, in the shopping centre alone, 100,000 square metres of lignacite was used. And by my calculation, that means that 12,300 tonnes of CO2 has been permanently locked up at Stratford. Other fairly large buildings that rely on lignacite, the 4 floors underground beneath the Shard are all built out of lignacite. So I'm kind of crossing my fingers that it's okay, because apparently the building next to the Shard, also made out of glass, the glass panels didn't do so well and started to fall off, and they had to replace them all. And my insurance is going to be tricky if anything happens to that. But lignacite has been around for 65 years, so hopefully this building will still be there in the next 65 years. Another building, the Gherkin. The whole of the middle of the Gherkin, the central core, the sort of backbone, is built out of our lignacite blocks where they run the lift shafts, and then they've cantilevered the glass off it. Ken Shuttleworth gave our lecture actually in the Gherkin in 2003 and explained it all to us. So wood is good. If you then, we're going to move back to ash now. It's no longer acceptable to dig holes and bury our rubbish. So an awful lot of rubbish, domestic rubbish, is put in a burner and burnt. That produces furnace bottom ash, which we use and many other companies use. However, it also, in the flue gases, produces toxic wastes which are captured, and this waste then costs about £100 a tonne to landfill. So we've hooked up with a company called Carbonate, and they've set up on our on our factory site at Brandon, and what they do is they bring that toxic material, they mix it with sand and cement and some liquid CO2, which is captured from the local sugar beet factory. They put it all in a mixer, whirl it up, and it carbonates. It turns it into a pelletized inert aggregate. We put that into our blocks. The blocks go to build the next burner. Very nice little virtuous circle. And in fact, this is the burner at Lakeside on the M4, M25 junction. You may have seen it. There's a sort of mad circular chimney that it has. They used lignacite blocks internally and our masonry externally. Very quickly moving on to glass. We started using waste glass in 2006. I was trying to produce a sort of modern stained glass window. So we produced this block with 100% glass, some white cement. I was then going to try and cut it very, very thin and get the light to come through it and look stunning. Well, it didn't work. It was a complete failure, in fact. But luckily, Alex de Rijker came and visited our factory and looked at it and liked the idea and said, well, can you do this with green glass and bigger bits, and adapted a bit. So we did that. And after several iterations, we came up with this block, which was hopefully then going to be used on the Olympic Village. This required us to source a great deal of green glass, and we couldn't get green glass at the time, and so we had to encourage all of our employees to drink a great deal, which they seemed happy to do. They brought the bottles in, we smashed them up, we put them into this matrix of limestone, and we then planished it, which is a sort of polishing which gives a polished but textured finish. Oh, you are wicked. Thank you. When we actually then came to supply the project, the ODA decided in their wisdom they didn't like green and they liked brown. And so we couldn't use the green glass, so we had to do a great deal more drinking. But the project looked stunning. I don't know how many of you went to the Olympics and saw any of those buildings. It was certainly impossible to get in beforehand, but they look wonderful now. Okay, just turning then very quickly to the future. What are the things that we are looking at for the future? Well, one of the things is self-healing concrete. So how does that work? What we're doing is we're exploring adding capsules of sodium silicate to our blocks, actually in the concrete. If then the building moves and cracks the concrete, it will crack the capsules. They break. The sodium silicate reacts with the calcium hydroxide in the concrete, which then binds it back together. I haven't got a clue what I've just said, but apparently, I'm told, if you're sitting next to a scientist, and we have got a few in the audience, they hopefully will explain that to you. But that is how it works. Concrete that breathes. Well, that sounds a little bit strange as well. But in fact, we already have concrete that breathes, and it's called Lignacite. We were approached by Kathy and Peter at 51% Studios 2 or 3 years ago to produce some nest boxes for urban birds. Here they are, out of our lignacite material with wood and concrete. And they put these up all around Bankside. And then we went back with Peter 2. Where is Peter 2? Peter Holden. And spent a very enjoyable Sunday morning walking around Bankside, looking at the hidden gardens, which were fascinating, and the birds. And the birds were back in town. The birds had moved back in to these nest boxes big time. Now, the Germans have done some serious study on this, and they have proved that wood and concrete hatch more young in a nest box. And the reason for that is that it's warm in winter, it's cool in summer, the wood absorbs moisture when it's wet, and when it's dry, it gives that moisture up. More young. If you don't believe me, this little blue tit bears witness to that. He is living in our one up, one down with balcony version. And I apologise for my old joke to those of you. Just on this theme, at the moment we are only using softwoods. And that's what we've done for 65 years, because that's what we've done for 65 years. But we're now exploring the idea of using other woods, such as oak, and all sorts of other things. Particularly following an interesting meeting in London, again with Alex DeRuyker, he suggested that we started using reeds, we looked at bamboo, and we're now putting bamboo into our concrete rather than using steel reinforcement. Bamboo, after all, is very strong, it's used all around the world, and it doesn't rust. So watch this space for that. Growing concrete structures. A friend of mine in Norfolk, who's a pig farmer, buys a lot of blocks from me, and he ordered a whole lot about 3 years ago. Our sand is delivered in large lorries, which also carry beans, and some beans happened to get into the sand, which we made into blocks, which we delivered to his pig units in Norfolk. He built his new pig units, and hey presto, 2 months later, the walls started to grow beans. His pigs were very pleased. He was okay with it, and it bore an idea for us that actually, why not? Why not concrete that grows? Why not concrete that goes green? And we're now working on something called green gabions, where you take a metre square, a metre cubed gabion, you fill it up with oversized large material, washings from quarries, other waste materials, and then you add whatever seeds or mix you want to fit in with the local environment. You put it in place as a retaining wall, the good Lord provides the water, and it goes green. So these are just some of the things that we are looking at. So to close, we live in an amazing and fragile world. This is a clownfish, a daddy clownfish, in fact, looking after his young and blowing water and oxygen at them. We need to learn from nature, very wise looking creature here, how to recycle our waste, how to use materials efficiently. We need to keep an eye on design so that our buildings adapt, alter, change, and meet the needs of our rapidly growing population. One of the things that has worked really well for us in the past is when we can persuade you busy people to come out and see us. We know about making concrete, we understand that. We don't know what you're doing with your wacky designs and your thoughts and what you're trying to do. And what, as I say, has worked really well for us is when we can persuade you to come out and look at what we're currently doing at particularly our factory in Suffolk, where we're doing a number of different things, and tell us what you would like to do, and we will have a go at doing it. That has worked terribly well in the past and has enabled us to be involved in some much more interesting projects and produce some really fabulous world-class buildings. So please can I encourage you to take that opportunity and do it. But above all, we want to live lightly on the planet and to enjoy the ride. Thank you very much for listening. I'm going to hand over to Michael, who is going to expand on these themes and I'm sure give us a glimpse of the future. Thank you.